All right. Thanks, everyone, for joining today. My name is Nick Vermondi. I'm a principal developer advocate with Ondat. And the goal for today would be to show you some demos around Ondat, and especially around the DevOps experience. So for that one, I'm going to focus on the developer experience when using Ondat during multiple stages of the software development lifecycle. Because as you know, one of the priority of Ondat is really to make this self-service model happen for the developer, or what we call, infrastructure that is getting shift left, so that there is no friction between developer and the platform teams, right? So we want everything. I mean, as a developer, I want everything as fast as I can. I don't want to interact with, many different teams, and I want the same experience regardless of my location. If I develop on my laptop, I want to be able to diagnose and troubleshoot problems very early in the development cycle. And for this, I may need a Kubernetes cluster locally, because we know, Kubernetes has a lot of, or implements a lot of different infrastructure services, such as service discovery, has a rich API, and people tend to extend the API a lot. So the whole notion of shifting left also comes with, this is fundamentally, it comes from software development lifecycle, which is basically trying to shift your, your CI left, your infrastructure left, your compliance left, closer to the early cycle of software development, so that you can prevent as much as you can any issue that are going to arise during production. So for this demo, I'm going to focus on an end-to-end CI/CD workflow that is Kubernetes. So that's another property we have at Ondat. We really want to embrace Kubernetes and be kube native and cloud native in all the possible senses. So it comes from the on-demand part, but also in terms of integrating with the Kubernetes control plane and all of the Kubernetes primitives, as well as the ecosystem we're going to see in the different tools that I'm going to be using during the demo. Another goal is that, I want to show you that we won't have any interaction with the infrastructure or platform team. The only thing we need to install essentially is Ondat, of course, and at least, I would say, one storage class so that the developers can consume. We're going to talk a bit more about that. So a couple of benefits hopefully you will get from the demo where I'm trying to make you understand. So again, shifting infrastructure left is very important at scale, but at scale it will be more the problem of the platform admin. This is not the focus for today. More the shifts, the developer experience left. Another benefit is we provide end-to-end on-demand resources for developer. And lastly, and this is also what I'm going to show as part of the demo today, platform engineer keep control with Git Ups principles. So I'm going to clarify what Git Ups means in that particular context. It can mean different things for different people. So I'm going to try to clarify this in a moment. And the different on that feature I'm going to show off today are the Kubernetes paradigm. So basically, showing how to configure Ondat just by using the Kubernetes native API and using it as the single source of truth. Of course, the simplicity of the configuration. And again, I want to contrast the simplicity of Ondat with, let's say, the proportional, I would say, complexity of the full CI/CD workflow I'm going to show you today. And last one, it's cloud agnostic. So what I'm going to show you is I'm going to start with a laptop, and then we're going to end up into a public cloud in production, right? So Git Ups, that's something I want to clarify before going further. As I said, it can mean different things for different people, but at the very foundation, if you look at the definition by Weave, because this is Weave who came up with this notion of Git Ups, it's not about Git hosting your configuration. It's not only about that. It's not only about using Git as the single source of truth. If you look at the slide, this is basically what a Git Ups pipeline will look like. On the top, this is more the traditional, let's say, pipeline where, as a developer, you just develop your code, you commit, you build your container, you use a CI probably to build your container, and eventually it will end up into a container registry. So far, so good, traditional CI. But now what makes the difference with Git Ups as opposed to a traditional CI/CD pipeline is the way it's going to be deployed into your Kubernetes cluster. So now going into the bottom, as a platform engineer, you also want to manage a repository where you have the Kubernetes manifest. So it can be another pipeline that is going to be triggered or that you can launch manually that is going to take the image the developer has effectively built in the container registry, bring that information and inject this into your application manifest. So you have something ready, like an encapsulation. Your application is entirely encapsulated, including your infrastructure requirement. And this is where Ondat here, and this is why I draw this Ondat icon, is because we also encapsulate the Ondat requirement into, as declarative format into those Git repository. So we have all those requirements, those needs that are encapsulated there. And then this is where the difference will happen. Git Ups means that you're going to be using a Git Ups tool to deploy those particular manifests into Kubernetes, but not in a push fashion. It's going to be in a pull fashion, meaning that you have usually what is an operator that is going to monitor those Kubernetes manifests repositories, and as soon as it detects a change, it will trigger another Git Ups pipeline. And this is the Git Ups pipeline. It's going to watch the different manifests. If it sees something that has changed, then it will trigger the Git Ups pipeline, which can include many, many things. But at the very foundation, it will be deployed. I mean, the goal is to deploy those manifests into Kubernetes production without using kubectl, without using any extra imperative command or security. And as a result, there's a couple of benefits, of course. There's more security because you don't log into the cluster as an admin to install things. There is more compliance because now those manifests, they are sitting in Git, and you can run any sort of syntactic policy software like OPA, Gatekeeper, this kind of things, right? So I just wanted to clarify this because we're going to be using Git Ups as part of the pipeline. So this is a simple pipeline, but here, in reality, what we often experience is a much more convoluted, sort of CI/CD pipeline, which is really looking like those complicated machine. And there's no exception for today, right? So this is what I'm going to show you today, hopefully, step by step. So the idea here is to start with, as a developer, I'm deploying code on my laptop. And for today, I'm going to be developing a Marvel application, awesome Marvel application. And the idea is because it's working, I have a stateless web server that I want to use inside Kubernetes, obviously highly available, many different containers, but stateless, so effectively replaceable. But I want to use MongoDB as my database to host all the API results, or the results of all my API calls I will be doing from the Marvel APIs, right? I don't want to be doing those API calls all the time. I just want to cache them into this database and have a representation of what is there for my application. And for this, of course, you need a stateful set, right? Which means that you will need Ondat locally if you want to use Ondat in production and have the same experience, be able, again, this whole shift left kind of paradigms, then you're better off with a consistent experience. And again, that's one of our goals, whether it's on your dev laptop, Kubernetes cluster, can be Kine, can be Minikube, anything really, or your production cluster here on the bottom, at the bottom, where you see it's going to be hosted in GK. So the pipeline is this one. First, the developer commit code locally on his station. It's going to be using directly with a commit locally. It's going to trigger a CI pipeline that is going to build the Docker image and push it to Docker Hub. And at the same time, because we are working in the development environment customize, which allows you to change, and we're going to take a look at this in detail, but it allows you to change to create manifest overlay depending on your environment. And this is where you're going to also specify the Ondat feature. So for example, here, storage class, one replica for development, that's okay. I still want one replica because I want to be able to, if one node in my development cluster phase, so I can just continue the development and the testing as normal, but just bare minimum. And then from there, I'm going to be using kubectl to deploy to the laptop dev cluster, which is not Git Ups, right? But things get a bit different when I want to push into my production repository. Then again, I'm going to be using a kube native CI pipeline, which is Tecton. So I don't know if you're familiar with Tecton. If you're not, I advise you to really take a look at it. It's really super flexible, can be a bit tricky. It's not simple. You won't do like a Tecton CI in 10 minutes. That just won't happen. But it is super modular, super flexible. And itself, it requires persistent volume. We're going to see how. But this is why I've also represented Ondat, because we can also solve some of the issues there. I'm going to build, again, the image using not Docker, because you should not build images with Docker and Kubernetes. Don't mount the Docker socket ever. Don't do that. It's not secure. So there is a Google project, which is called Canico, that allows you to build container without having to mount Docker sockets, which is great. Again, image is going to end up into Docker Hub. And then same principle again, customize to build the production overlay with the new Ondat feature. And because we are declarative, we'll just implement those features into the production cluster, but this time using FluxCD. So quick shout out to our friends at Weave. That is basically going to provide this Git Ups pipeline, monitoring the repository, and when it detects changes, going to the GKE cluster, pulling all those manifests and deploying this. So the first thing I want to show you is my development cluster. So simply kubectl get node. I've got 2 nodes on my laptop, and then I can also show you that I don't have any pod running normally. I don't have any PVC running yet, hopefully. Basically nothing, right? So let's move to the development environment. So here I'm on my laptop, and the first thing I want to do, I've got on the left, you can see all the different files. It's just, Docker file, my application is there, nothing really fancy. But what I want to do is just, do some modification and trigger the first pipeline. But before that, I want to show you what is on my customize. So you can see here on the left, I've got everything represented as, a YAML file, which is the whole configuration for both the developer cluster and the production cluster. The only difference is, in the different overlays. I've got the base on the top. If you're not familiar with customize, like explain it quickly. I've got my base manifest for my application, just a template. And then I can apply different overlays to override some of the components. And of course, that includes the storage part, right? So for example, here, I'm going to say for, Ondat dev, I just want one replica. This is my way to configure Ondat kube native, just using parameters and label. For production, then I don't want this. I want something more specific, or I may want to leverage an existing storage class. So I will want to have more replicas and more feature available. We're going to see this in a minute. But that's basically the principle. I'm going to leverage this configuration for that and the customize command line. So let's add a new file, for example. So test1. Okay, so I'm just going to commit this file, and what I'm expecting now is to trigger the pipeline so that is getting deployed onto my development cluster, cross finger. Okay, so now what is happening, I'm building the cluster. I'm building the application. If I go there, I should see something. Yeah, so now everything is getting deployed. So not only my front end with my application, but as you see, I'm also deploying locally my MongoDB cluster as well, right? So because it's stateful set, so I don't know if many people are familiar with stateful set, but in Kubernetes, stateful set has some specific properties in the sense that it will be provisioned a little bit slower than traditional stateless container because they are considered as pets, not as cattle. So you can see the first difference is there, this random kind of name. If I destroy one, another one will pop up with a very different name. If I kill MongoDB 0, another container called MongoDB 0 will pop up and it will attach to the same volume as well, right? So it's really about a stable identity in terms of naming. Not necessarily IP will change, but the name will stay the same. It's about having one container at most all the time, including when you are upgrading or doing any kind of operation. So Kubernetes guarantees this for stateful sets, very important construct for database. You won't build a database out of Kubernetes deployment. So I can see that now it should be all right. I've added my data. So the application itself, as I said, so it should be okay now. So I can maybe show you the app quickly. So I've got my 3-node cluster, MongoDB, I've got my application front end. But before going to the application, what just happened here, right? So that's interesting to see. So if I've got 2 storage class here that are provided by Ondat. And if I look at my, for example, MongoDB, here you can see that in the template, this is also how I want to specify what kind of storage I want. So I define a volume claim template, which is a bit different from other construct in like a simple persistent volume claim. Here, the difference is that it's going to be provision 1 PVC per pod, as opposed to 1 PVC for the whole deployment, which is a big difference. And I want it to be deployed because we automatically deploy the PVC, the PV, everything. It's a dynamic provisioning, meaning that the only thing as a developer I want to care about is the name of my storage class. I don't care about the rest, really. I don't want to be dealing with PVC, with PV. And yeah, it's boring, it's not interesting, can be complicated. Here, simple, 1 storage class. And of course, the storage class will have the property I've mentioned before in the parameters, and I'm sure I will have the right environment, will have the right feature from Ondat. Okay, so now what we can do is maybe we can also take a look at the storage OS or Ondat cluster. So should be this one. Okay, I can do.
Nicholas, I have a question.
Yeah, sure.
Hi, Ned Bellavance. Regarding the 2 different storage classes, they're both using Ondat, correct?
Yes. So the first one, the fast, is coming by default when you install the solution. The other one is one I've specified myself.
Okay. Are they both using the same backend storage? Like, what's the difference between the 2 storage classes?
The configuration. The feature that you want to enable.
Okay, so one's not necessarily faster than the other. No. It's just what feature sets you want to have for a particular volume. Okay.
Correct. That's right. That's right. And one of the interesting properties that we have is, so you see here location and attached on. Ideally, we want to be attached on. Attached on mean where we are presenting the volume. So essentially where the pod is running. Location means where the particular volume, primary volume, is located. So ideally, we want to collocate the pod with the volume. But the good thing is we don't have to, right? Which obviously allows you to have a lot of different scenarios. Failover or failure scenarios that you don't really care about, right? If for example, the pod is moved, let's say your pod is moved to another host for whatever reason, it can still access the volume that is local. Or obviously, if the node fails, the pod can be restarted on another volume or on another node, and the volume can be then represented, promoted to another node as well, right? Or to the same. We will have the right algorithm to basically provide the best possible placement, right? If that makes sense. Okay, so now I've got my MongoDB that is safe, is consuming storage from Ondat. Now, what about my application? Hopefully it should be running. So I just have to here. That's this one. And so if my MongoDB is working, then I should see some. Okay, so it's there. This is my nice Marvel application. I should be able to. So the data is really composed of random, character that are stored in the database. So if I reload, this is going to be doing a request to the database, right? So this is working. This is perfect. So now, second part, I'm happy with my application, is working as expected. I want to develop into production. Now, like this is the serious stuff is going to start, right? So for that, I'm going to push. And these two solutions, I can trigger it via webhook, but I didn't do it for today, right? So I'm going to trigger the pipeline manually. So it's more like to show you probably like a, maybe the platform admin could also be involved in that one. And the idea is to trigger now, if I go back to the slide very quickly, just to show where we are. So we've seen this, right, on the very top. Now we're going to see this part on the bottom. So now I'm going to trigger the Tecton pipeline, and this one is going to be responsible for all the rest. So while it will be deploying, I'm going to explain like a couple of things, but first let's trigger. Again, remember I said this is full Kubernetes. Tecton is a CI that is consuming its own dog food. So every task, every step is a container. Then we're going to follow up what's going on. And at the same time, I'm going to monitor what's happening on my production cluster.
So Nicolas,
yep.
I have a question here.
Sure.
So what happens if I'm running in a very complex environment with full of namespaces and application? Let's say 200 nodes. I don't know, 500 applications and everything, and I want to add 50 nodes because I need some additional capacity. And
you need
and I don't need to change anything, but I need to give more resources, performance, everything to my applications. So I don't care about day zero. I want to know about day two.
Yeah. So basically, our solution works based on daemon sets. So then it's up to you to determine how you want to add your nodes. So typically, it will be maybe a auto scaling, it's common. So let's say you do cluster auto scaling, then as the nodes are added into the cluster, automatically the Ondat solution will be installed on them because we provide a daemon set. So there's nothing to do, literally. That's it.
Okay. So, and everything is rebalanced automatically?
No, I mean, a pod, once it stays on a node, it will be on the node forever until you evict it, right? So you need to have Kubernetes events. Once a pod is scheduled on a node, it will stay there until there is an event. Event can be contention, so you can base rule if you're consuming too much memory, maybe the pod will be evicted and restarted on another node. Even for stateful sets, right? So this is why it's important to have a PV or distributed data service that you can trust, right?
I understand the front end, but in the back end, I mean, I'm doing all of this to have more power in general, more capacity. More
Yeah. That's fine. Then it's just the daemon sets. We implement our intelligence there by default. Daemon sets. So as soon as the node pops up, Ondat will be installed. The node will be ready to host any sort of Ondat volume.
I have the 3 replicas now in my.
It won't be reshuffled.
I want to move some of these replicas in other nodes.
Yeah, so it won't be reshuffled. Again, you need to have an event to cause volume reshuffle. If you want to reshuffle volumes because you don't like the way it's shuffled, and this is another thing I want to show in the next demo, is that you can reduce the number of replicas to 0 live, and then bring it to the number you want, to up to 5, and this will be reshuffled. So you can reshuffle manually if you want, but by default, we don't reshuffle.
What are the resource requirements of the daemon set pods? I mean, just a rough idea. I realize it'll be different in different scenarios, but are we talking,
like 100, a memory and CPU?
Like 100 megs of RAM, or is it a gig of RAM, right?
Minimum, I would say 1 CPU, a gig of memory. It depends. It's proportional to the amount of volumes you have and the amount of input-output operations that you need for that volume. So bare minimum cloud machines that are small are fine.
Okay, thanks.
So another point I wanted to mention, which, to be honest, I discovered it as I was doing this demo. So Tecton, as I said, is very popular in Kubernetes environment because it's eating its own dog food. But what from one task to another, what you have to do, like in this particular pipeline, I'm writing my customized manifest to a particular repo, and I need to share data between 2 different tasks into that repo. And the way you have to do it with Tecton is by using PVC. But the problem is you cannot have more than 1 PVC because of the way they work. You can disable their feature that allows you to, collocate the pod with the volume. If you do that, then this limitation doesn't apply, right? But guess what? We provide that feature. Regardless of the volume location, we can get the pod access to it across the network. As on the front-end part, it still thinks it's local. So which allows me to do this very thing, which is have 2 different volume claim templates mounted into Tecton. I mean, this is huge. I mean, this is a big limitation in terms of the different pipelines. And now with Ondat, I didn't know it, but now I know it. I will use it all the time. So it can solve. So my point is, it can solve like unexpected kind of situation just because of our data plane properties, even though we are completely integrated with the Kubernetes API and control plane that is driving essentially everything. So you can see here, this is where I specify the new storage class I want to use in production. So let's take a look in the production thing. So you can see that it's been deployed, but I didn't do anything manually. And actually this is Flux. So Flux, normally I should have, if it worked, it worked because I've got my application deployed. It doesn't do it justice because there's a lot of moving part happening in the backend, but basically this is what it means. Flux has been monitoring my repository, and as soon as Tecton has pushed my storage definition, my application definition, it downloaded everything into Kubernetes and made sure that the application is now ready. If you look at my application right now, it's a bit different than before. I've got a bit more front end. I still have like 3 nodes for the backend. I've got a bit more front end. And in terms of the storage class I'm using, if I do sts mongo db-o YAML, this is Ondat with our disaster recovery, topology aware placement that I'm going to show you in another demo as well. But let's take a look at the storage class that is there, right? So let's see, this is on that tab, -o YAML. So you can see that I've got a couple more features that are enabled. So essentially, I wanted to have encryption, which where is it? Oh, I forgot to add it. Anyway, so the topology aware, which is probably the most important I wanted to show you, allows you into this gigantic cluster, like 6 nodes spread across 3 availability zones. It will allow you to explicitly mention that you want the volumes replicated into different availability zones, that I don't want to have more than 1 volume at any point in time. You can have more because there's only 3 availability zones. So you will have more if you have more replica than availability zone for sure. But let's say if you have 3 availability zone, if you have 3 volumes, they will all be sitting in different availability zone, right? So this is the last part I wanted to mention. So last but not least, let's just check that our application is working again. So hopefully, did I kill it? Yeah, it's killed there. So now it's running. The only difference is that now it's running into production with augmented Ondat configuration and features.